Here's an application problem for linear inequalities. So we've got College A charges $500 per unit, and College B charges a flat rate of $5,000 up to 15 units, then an additional $1,000 per unit above 15 units. And the question is, when is College A cheaper? So there are a couple things I want to do. First of all, I want to let X be the number of units. And the second thing is I want to make an inequality using this information that College A is cheaper. So cheaper should mean less than the cost of College B. So once we've set up this inequality, we want to write expressions for cost of A and cost of B. So College A charges $500 per unit. So that cost is relatively straightforward. It's just going to be 500 times the number of units, which I'm going to say is X. But the cost of B is more complicated because there are actually two different functions that I'm going to use to represent the cost of B. One is that we have a certain price up to 15 units. And so for this cost of B, I'm going to write it as a piecewise function. And the first formula is simply 5,000. Because there is a flat $5,000 charge, no matter how many units you have, whether you have 5 units or 10 units, as long as the number of units is less than or equal to 15. So that's up to 15 units. The next part of this piecewise function is a little bit more complicated. So the cost above 15 units is going to start off at that base of 5,000. But on top of that, we're going to add on $1,000 per unit, but not $1,000 for every unit, but for every unit above 15. And so we're going to have to say that this is X and then minus 15 because we don't pay an extra $1,000 for the first 15 units. And so this portion of the piecewise function is defined for X greater than 15. And so when we take a look at the inequality, we are going to be concerned with two different parts of the inequality. So the first part is for X less than or equal to 15 units. So if we've got 15 units or less, when is the cost of A going to be less than the cost of B? So if we take a look at this expression, cost of A again is 500 times X. And we set that less than 5,000. And now we can solve for X. We just divide by 500 and that X is less than 10. So we can see that if there's a small number of units, being charged by the unit is a better deal than paying a flat rate. Next, we want to look at the second condition. And that is when X is greater than 15. So if we take a look at this inequality, on the left we still have 500X, but this time on the right we have this slightly more complicated formula. So we've got still this inequality less than, and then we have 5,000, and then distributing we have plus 1,000X minus 15,000. So simplifying, we've got 500X on the left, 1,000X on the right. If we subtract off, we get 0 on the left is less than, and on the right we have 500X. And combining these two terms, 5,000 minus 15,000 gives us minus 10,000. Solving for X by adding 10,000, we've got 10,000 is less than 500X. And finally solving, we can get 20 on the left is less than X, or that X is greater than 20. And what this indicates is that there are actually two regions when college A is cheaper. On one hand, we can see that college A is cheaper when X is less than 10, and so that would be for less than 10 units. And the other time when it's cheaper is for X greater than 20. That is, for X is more than 20 units. And we can kind of think of this intuitively. When we have a 500 per unit charge, that cost is going to be relatively low if the number of units is very small, because the flat rate of 5,000 is a moderately high charge, and so that cost A is going to be below the flat rate cost for less than 10 units. However, in the middle, when you're charging $500 per unit, that per unit cost begins to add up, and then the $5,000 flat rate becomes more economical. However, once you get above 15 units, adding an extra $1,000 per unit causes the total cost to go up even faster than for college A. And so you can see there is a certain point at which the cost of college B passes college A, and that is for more than 20 units.